Hello, Algebra 2 people. How you guys doing? Hope you're finishing up with that Chapter 8 test. I'm going to grade those at the end of the week, so if you could get those into me before Friday around noon, that would be great. I'll print and grade the ones that I have so far. All right, this is our last chapter of the year. We're going into rational functions. Basically, we've got fractions in the mix for this chapter, variables in fractions, what happens with the graphs on those, and today it starts out with a basic inverse variation lesson. So just to remind you, we did do direct variations before. Can you remember the formula for that? The little equation? It's y equals kx, where k is my constant of variation. So we still use that k notation for the constant of variation, but with inverse variations, which is today's lesson, we've got y equals k over x. So notice the x now is in the denominator. It's varying inversely. There's a restriction. K cannot be 0. So our constant of variation cannot be 0. It's true in both cases, direct and inverse variations. If k was 0, look what would happen here. It would just be y equals 0. And that would give us the x-axis. We'll get into the graphing of this stuff in the next lesson. So here's a couple of ideas that go with this. If we solve for k, so I divide both sides by x, I get k equals y divided by x in a direct variation. So if I divide the y by the x, and I get the same number every time in a table of values, that tells me it's a direct variation. And now if I solve for k in this one, multiply both sides by x, I get k equals the product of those two. Now I did y times x, x times y, same thing. And so the product is always the same number in inverse variations. All right, well, let's try the first example here. So let's suppose that x and y vary inversely. And we're going to say x is going to be 7 and y is going to equal 4 in this problem. And then the instructions would be something like write the function that models this. So we know it varies inversely. So I can say, all right, well, that's this y equals k over x formula. And then I can just put my two numbers in and solve for k. So if I put the 4 in for the y, and then I have the k over the 7, then I just have to multiply both sides by 7, and I get my k to be 28. And so the model, or the function that models this, is just going to be y equals 28 over x. Final answer. Nice. Okay. Actually remembered to move this up ahead of time. That's good. All right, second one. So they're going to give us tables and ask us, is this a direct, inverse relationship, or neither? So here's my first example here. What if I had, I'll do it horizontally, so I'll save myself a little space, 2 and 0.7, 4 and 0.35, and 14 and 0.01. So there's my table. That's squiggly. And now, am I multiplying the x by something and getting y? Am I multiplying by the same thing each time? That's not working. And so the next trick is try the division. So if I divide 0.7 by 2, if I divide 0.35 by 4, if I divide 0.01 by 14, or maybe neither of them work. So you just got to look. Is it the product that's happening? If it's the product, it's an inverse. If it's division that's happening with the y and the x, then, and you keep getting that same constant, it's a direct. And if neither of those things are happening, then it's neither a direct or inverse. And so this one, it's actually multiplying to be the same amount. 2 times this 0.7 is 1.4. 4 times a 0.35. You can see I just took half of the 0.7, but I doubled the 2, so we ended up at the same place, 1.4 there. And if I do 14 times a 0.01, I get 1.4. So remember, when the k is the product of the two things, that's actually an inverse, because I could divide away the x and get my y equals k over x. This first one, it is an inverse relationship. All right, second one here. Get this arrow out of the way. Now if I have x and y, what if this is negative 2 and a 6, negative 1.3 and a 5, and 7 and a negative 4? So there's my 3 ordered pairs for this one. And so I'm looking, all right, am I multiplying the same thing by x each time? So I need to multiply this first one by 3 to get a 6. If I do a 3 times this negative 1.3, that's not going to work. So I know it's not an inverse one. What about dividing? 6 divided by the negative 2, 5 divided by the negative 4 divided by the 7. That doesn't work either. So this is a neither. So I'm just doing products of x and y to determine if it's inverse. I'm doing the division of y by x to see if it's getting the same constant of variation for a direct variation. And then if neither of those things work, then it's neither. All right. I suspect you might guess what this next one is going to be, but let's just look at the numbers first. 4 and negative 10 and 6 and negative 15. All right. So if I do the product, negative 2 times 5, negative 10, 4 times negative 40, that doesn't work. How about the division? 5 divided by negative 2, that's negative 2.5. Negative 10 divided by 4, negative 2.5. And this one also, negative 15 divided by 6. So since the division of y by x keeps giving me the same amount, that tells me my constant of variation is for a direct variation. All right, one last problem for this section, and then we're done with the first half. So the third problem gives us pressure. It's another table. I'll do it vertically this time. 3, 5, and 8. And then volume 32, 19.2, and 12. And here they tell us that pressure has an inverse relationship with volume. So the more pressure we put on gas, this is talking about gas here, the less volume it has. The bigger the pressure, the less volume, as you can see. And so since they tell us ahead of time it's inverse, basically what we need to do is figure out what our k is. So we know y equals k over x for inverse variations. And so in this case, which one is the independent, which one's the dependent? The p here is the x, that's the independent. So when we multiply here by both sides, we get 3 times 32, giving us the k of 96. And they told us already it was inverse, but if we were just checking, same thing, 5 times the 19.2, that gives us 96, and of course 8 times 12, that also gives us 96. So what's our function? Y equals 96 over x if we use y and x, but they used p and v, so final answer would be p equals 96 over v. All right, whoops, that's the first half of the lesson. All right, here we go to the second half. Hang on just a second. Now for this part, you're going to want to go and look at all the examples on page 480 in the green box. I'm not going to read those through with you guys now, but no, there's a lot of good examples to look in that green box. It kind of summarizes this idea of what are called combined variations. So like it suggests, combined means there's going to be more than just y and x. There's going to be a third or a fourth variable in the mix. And so one example that I've got here for you relates the mass of a moving object. That's going to be m for mass. And that equals 2 times k, that constant of actually kinetic energy, sorry. So m is the mass of moving object. K is the kinetic energy of that moving object, and then there's an inverse relationship that the volume, or velocity, excuse me, is squared. So V was velocity. And they tell you these values in the problem here. And then they're asking describe, so this is how the problem would be asked of you. Describe the relationship as a combined variation. Basically, it's asking us to use words to describe this relationship between the mass of the moving object and the kinetic energy and velocity that occurs. And so we would start this out by saying m, this thing here that's by itself, varies, like in those examples, and then it's going to be directly with k We don't have to worry about a regular number in these. You don't have to mention those. It's just the variables that you're talking about. So it varies directly with k and inversely with the square of v. And these don't have to be worded exactly, something to that effect. And inversely as the square of v. You can word it different ways, but that's the idea. Is can you put this equation or formula into words using this varies directly, inversely, squaring, cubing, all the different variations that you'll see. All right, one more example. This has got numbers in it. So they tell us z varies jointly with x and y. So here they've got the words describing it, kind of going backwards. Can we make up an equation? And then they're going to tell us some numbers here. So say when x equals 2, y equals 3, then you get z equals 60. So they say when x is 2, y is 3, you get 60 for z. Figure out the equation, write the equation. So that would be part A of this problem. So z, start with that, varies jointly, so equals, and that just tells me that both of these things are connected, and that implies multiplication. Don't forget our constant of variation. We have to figure that and get a number for that. would look like this. So there's no inverse in this one, so there's no fraction with this one. And so now I can put my numbers in and solve for k. Well, they told me that 60 happens when you put a 2 in for x and a 3 in for y. Well, that gives me 60 equals 6k. Divide away the 6, tells me that the constant of variation in this problem is 10. So what's the equation final answer going to look like? Z equals 10xy. Final answer for that equation. And then they'll ask a follow-up question. Well, what if x was 4? Whoops. Oh, darn it, that got covered up. Well, I'm not going to go back and retape this so bad, so I'll just quickly go over this again. So z varies jointly with x and y. X equals 2, y equals 3, z equals 60. Then I wrote my equation. I think you could see that part. And then I put my numbers in and figured out k was 10. And then now they're asking, well, what if 4 and 9 were the values of x and y? Then what does z equal? So this would just be drop those two numbers in and solve for z. In this case, pretty basic arithmetic here. We're just doing 10 times 4 times 9. And so that would give us 360 for z. Whoops, did it again. They're hiding. Sorry. I need you guys to tell me to scroll up and scroll down. Alright, here's the assignment. It's on my website as well, but it might be easier just taking it from here. 2 through 36 evens, and 49 to 51. Alright, 5 more lessons of the year. We'll see you soon. Take care.